Number 12 from the fall 2012 exam 4 asks us to determine the mass of an object. Okay, so that's a little different. So let's see what else we have here. We're told that a point mass is attached to the bottom of a 2 kilogram thin rod. Okay, so we have two parts, the rod and the point mass. We don't know the mass of the point mass. That's what we're trying to find. We're given that a torque of 40 newtons is applied to the combination, and the angular acceleration is that value. Alright, so we'll have a torque, 40 newton meters, and we'll have an angular acceleration, which we called alpha, of 4 radians per second squared. Okay, so that right there should, and we're asked for a mass of the object, which is factored into the moment of inertia, so that right there should remind you of the equation we had, torque equals I alpha. Okay, we know the torque, we know the alpha, so we can find the moment of inertia of the whole system as torque over alpha, 40 newton meters over 4 radians per second squared. And just to get our units a little bit more usable, we'll write 1 newton is a kilogram meter per second squared. Okay, so newtons will cancel out. Second squared on the bottom here, second squared on the bottom here cancel out, radians unitless, and so it looks like kilogram meter squared. Alright, so 40 over 4 is 10 kilogram meter squared is the total moment of inertia. So I'll label that as total. Okay. So then we break the problem down into the total moment of inertia is equal to the moment of inertia of the rod plus the moment of inertia of the object, our point mass. Okay. We're rotating about point A, so let's remember that. So everything has to be this total I we calculated based on the torque and the angular acceleration is about point A. So everything else has to be about point A. So we're going to have to apply the parallel axis theorem because the rod's center of mass is right there. Okay. So I of the rod about point A is really I of the rod about its center mass plus md squared. Okay, so there's the I of the rod about point A, and I of a point mass is just m. Let's call it L squared, where this, I'm going to call this L. Okay, so that is that. We want to find the mass of the object. This is the mass of the rod. Okay, we have an equation. We will give you equations for that in this problem. If I scroll back to the top, I about the center mass of a rod is ml squared over 12. Okay, so we'll factor that in. Mass of the rod, the length of the rod squared over 12 is that part. Okay, this is the mass of the rod. The distance is from our rotation point. Let's scroll back up here. Our rotation point to the center mass. So that's half of the length, or 3 over 2. And that distance got squared. Okay, so again, this quantity right there is the I of the rod about point A, which is center mass plus parallel axis theorem. And this is the mass of the object. And the length is 3. So let me go ahead. 2 kilogram rod. So let me go ahead and plug in the rest of my values here. Well, let me work symbolically first. I think it's a little bit easier. And so I'll be consistent. Put that in symbolic terms as well. So that distance was L over 2, quantity squared, plus ML squared. Okay, so now we can plug in some numbers. So we'll have 10 kilogram meters squared is equal to, that's the mass of the rod, 2 kilograms times 3 meters squared over 12 plus 2 kilograms times 3 meters over 2 squared plus the mass of the object times 3 meters squared. Okay, so I will bring the calculator in, and then we'll take 10 minus 2 times 3 squared divided by 12 minus 2 times 3 squared divided by 2 squared. Let me back up and do that a little differently. So I'm right here. I'm on my 2 times quantity 3 divided by 2 squared. Okay, so that will give me that minus that minus that, and I divide by 3 squared to get my m. Divided by 3 squared, 0.444. So m0 equals 0.444 meter squared, kilograms, so mass is going to be in kilograms. Okay, 0.444 kilograms. Key points were to realize that this equation gave us the total moment of inertia, and that the total moment of inertia was these two parts: the moment of inertia of the rod about point A and the moment of inertia of the object about point A. The object was a point mass, mr or md squared, and the rod was its center mass moment of inertia plus the parallel axis theorem with the appropriate distance.